In this lesson, we will examine what is meant by the term wake turbulence and how it can affect your aircraft. The term wake turbulence is used to describe the effect of rotating vortices of air generated behind the wingtips of aeroplanes. They are present behind all heavier than air aircraft when they are generating lift, but are particularly severe when generated by larger types. Wake turbulence is most hazardous to aircraft with a small wingspan, and especially during takeoff, initial climb, final approach and landing. The characteristics of the vortex are determined by the aircraft gross weight, the wingspan, airspeed, aircraft configuration and attitude. The vortex patterns from an aircraft may be regarded as two counter-rotating cylindrical air masses trailing from the aircraft wingtips. In an aeroplane with a symmetrical or near-symmetrical aerofoil, such as an airliner, wake vortex generation begins when the nose wheel lifts off the runway on takeoff and ceases when the nose wheel touches down again. Typically, the two vortices are separated by about 3/4 of the aircraft wingspan, and in still air tend to drift slowly downwards at about 500 feet per minute. On approaching the ground, the vortices may move tangentially at high speeds in excess of 300 feet per second, around 180 knots, from the track of the aircraft in still air, but then decay rapidly to an average sideways speed of 5 knots. In a crosswind situation, the outward path of the upwind vortex will be opposed by the crosswind, whilst the downwind vortex will be assisted in the outwards dispersal. If the crosswind component is 5 knots, the upwind vortex will remain dangerously over the runway. Atmospheric turbulence and high winds close to the ground cause vortices to decay more quickly. Thus, it is in conditions of light winds that we must pay additional attention. The greatest wake turbulence is generated by large heavy aeroplanes, which are flying slowly and in a clean configuration. That is, flaps and wheels up. The wake vortices from a helicopter are generated by the downwash of the main rotor, which is transformed into a pair of trailing vortices similar to those of fixed-wing aeroplanes. Evidence suggests that per kilogram of aeroplane mass, helicopter vortices are more intense than those of fixed-wing aeroplanes. ICAO defines wake turbulence categories of aeroplanes by maximum takeoff mass, as shown on the screen. Separation minima are applied to aircraft under the following circumstances. First, when two aircraft are using the same runway or closely separated runways for takeoff, a missed approach or landing. Second, whenever a following aircraft is at the same height as or less than 1,000 feet below the leading aircraft. Wake turbulence separation can either be based upon time through procedural separation or distance through radar separation. The approach to land is a particularly important phase of flight, so we will now discuss the wake turbulence separation minima that will be applied to arriving aircraft. For non-radar, that is procedural separation, a medium category aircraft following a heavy must maintain a minimum of 2-minute separation. Light category aircraft following a medium or heavy must maintain at least 3-minute separation. Using radar separation, the distances shown on screen apply. Wake turbulence separation on departure is the minimum time from when the leading aircraft becomes airborne to the time when the following aircraft becomes so. However, not all departing aircraft take off from the same runway, and this adds a degree of complexity to the separation. A minimum of 2-minute separation is applied between a light or medium aircraft taking off behind a heavy aircraft, or a light aircraft taking off behind a medium aircraft, both under the following conditions. aircraft are using the same runway, or parallel runways separated by less than 760 meters, or parallel runways separated by at least 760 meters if the projected flight path of the second aircraft will cross the projected flight path of the first at the same altitude or less than 1,000 feet below it, or crossing runways if the projected flight path of the second aircraft will cross the projected flight path of the first at the same altitude or less than 1,000 feet below it. The wake turbulence separation rule for departure changes when the takeoff run of the following aircraft commences at an intermediate point on the same runway or on a parallel runway less than 760 meters away. In this case, the separation minimum is increased to 3 minutes for a light or medium aircraft taking off behind a heavy aircraft, or a light aircraft when taking off behind a medium aircraft. As with the takeoff from an intermediate point, separation minima on departure changes for runways with displace thresholds. There are two important parts of separation on runways with displace thresholds. The first relates to the separation between an aircraft taking off after another has landed, and the second, which is the opposite scenario, is for an aircraft landing after another has just taken off. For the first case, there is a 2-minute minimum separation between a light or medium aircraft taking off after a heavy aircraft has landed, and between a light aircraft taking off after a medium aircraft has landed. For the second case, there is similarly a 2-minute minimum separation between a light or medium aircraft landing after a heavy aircraft has taken off and their projected paths cross, and between a light aircraft landing after a medium aircraft has just taken off. The last variation to the wake turbulence separation minima rules is when a takeoff and/or a landing takes place in the opposite direction to an aircraft executing a missed approach, thereby carpeting the runway with its strong vortices. Remember, it is slow, heavy, clean aircraft that produce the largest vortices. If a medium or light aircraft wishes to take off in the opposite direction to a heavier aeroplane initiating a missed approach, separation must be at least 2 minutes. Similarly, when a lighter aircraft approaches to land in the opposite direction to a heavier aircraft executing a missed approach to the same runway or a parallel runway less than 760 meters away, 2 minutes separation must be applied. These special cases complete our investigation of wake turbulence and separation minima, both in radar and procedural environments.